Hi folks, Buckley here. In this video we're going to practice making our very first assemblies. Some of the stuff that we're going to cover in this video includes how to import parts into assemblies, how to orient those parts relative to each other using something called mates, and then we're going to discuss two of the most common mates that are going to be particularly useful for some of the assignments coming up. So in order to facilitate this, to make this a little bit quicker, I've included two part files that we're going to work with. I'd like you to follow along with me. One part is called a bushing, and this bushing is a 2-inch square with a 1.01 inch hole in the center of it that goes all the way through. The other part that we have is a shaft, and that shaft is 6 inches long, and the diameter is, I believe it's like 0.9 inches. Okay, so what we're going to do here is we are going to put two of these bushings together, and then we're going to insert the shaft down through the center of those two bushings. We would like the shaft to be able to spin, but not to move in and out. So we're going to play around with a bunch of different mates in order for that to happen. But let's first start by making an assembly. So I can do this from any space here. I could start with a part open, or I could open part files, but basically what I'm going to do is I'm going to drop down and do make assembly from part/assembly. Okay, that's going to open up a new file. This is a new type of SOLIDWORKS file called an assembly file. I'm going to start by pulling the bushing in. So the first part that you pull into assembly space, so this is wide open space just like you're used to with your parts, except this space you basically only do one thing. You pull in different parts and you orient them relative to each other using something called mates. So I'm going to start by pulling in a bushing. I've selected that. I'm going to hit OK, and it's going to plunk that bushing down. It's plunking this bushing down in 3D space in the same kind of way that, basically the same orientation that you drew it in. Okay, and one important thing to remember is this first part that you put down into assembly space is fixed. It's like it's glued down in 3D space. The way that I can tell it's glued down is there's this little F that's in the prefix, so you have your history just like you do when you're making a part, but basically the only two things that are going to happen in assembly space is you're going to see more and more parts that are added. And if I drop down, you can see this is how I made this part, right? So this is the exact part file, it's just pulling that in. This little F in front of bushing, which is our first instance of this part, just says that it's fixed in space. Okay, so I can't move this part. I can relax that if I want, but there's almost no reason to do that right now. Okay, I have the same zoom commands and reorientation commands that I do in part space. So my roller is taking me in and out, and if I hold down that center roller, it's allowing me to spin the entire space. Okay, I said I wanted two instances of these bushings and I want the whole to be aligned, so let's go ahead and do that. So I'm going to do another insert components. Notice that another tab has come up here. So we used to have just layout sketch, right? Now we have this assembly tab because we're in assembly space. So I'm going to do the drop down insert components, and this comes up again. I'm going to select another instance of the bushing. Okay, and when I do that, you'll notice that, and if I pull over, I've clicked, I've done nothing else. Okay, I've basically got my bushing kind of floating around here in space, and I can plunk it anywhere I want. This little hot button here allows me to reorient the bushing in all different directions, right? So I could reorient it all over the place before I plunk it down. That can be kind of helpful. So I'm just going to drop it way over here in space, then I'm going to spin space around. So to drop it, I just left-clicked. And you'll notice these things aren't where I want them yet. So let me get kind of a handle on how things are attached right now. So I told you that this guy here, which was the first instance of the bushing, that's fixed to the background. You notice that that F, right, denotes fixed, and it is not present on the second instance of the bushing. So this instance here, if I were to left-click, I can drag it around in space, right? If I am to right-click and hold, I can reorient it. I can spin it. Okay, this tells me that this guy here is not fixed down in any way, shape, or form to the background, or it's not positioned at all relative to this other fixed piece. So this is where the mates come in. Okay, so we're going to need to tell SOLIDWORKS how these two parts should be oriented together. I would like to pretend that these guys are going to be glued together. Okay, they're going to be glued together in such a way that all the sides line up and that center hole lines up. So let's practice all the ways that we can do this. Okay, so first I'm going to click on mate. Mate is how we prescribe how things are positioned relative to each other. There's a couple different options here. The ones that we're going to practice with today are coincident, parallel, concentric, and then this offset. So again, we're going to do coincident, maybe some parallel, concentric, and an offset. So I would like to first show you how coincident works. So coincident can be applied to points, lines, and planes, right? So let's first start with points that are coincident. Let's say that we make this corner and this corner coincident. It's immediately going to tack those two corners to each other. And let's watch now how, if I were to try to move this piece, right, it's like it's stuck right on that corner. Stuck right on that corner. So one way I could glue this together is going back and saying, okay, well, I want, oops, I don't want that guy. I want this corner. I'm going to tack it in multiple points. This is not the most stable of mates, but I will show you what this looks like. Okay, so at this point, I got two corners tacked down. And you'll notice what can happen here is, so SOLIDWORKS doesn't know that these objects can't go through each other. There are commands we can use to prescribe that, but for right now I've got these two tacked down, and this guy can just keep spinning around, right? And keep spinning. Okay, so if I do one more corner, that may be another way to tack this down. So that is a point, point, point coincident mate. It's okay, it's a little clunky. It's hard sometimes to contact those points. So you'll notice under mates, I got these three drop downs. I'm going to go ahead and relax those by basically deleting them. So I'm going to get rid of those mates. And when I do that, right, I immediately can pull these guys apart. Again, I can reorient them, right? So I can pull this out in space and I can kind of move that again. So that was the point, point, point mate. I am going to try a different mate. Okay, so this different mate has us using coincident this time with different faces. Okay, so faces can be coincident as well. So if I make this plane and this plane coincident, right, what's going to happen is that these things are going to line up, and this guy can move in that plane, but this plane and this plane are always going to be lined up with each other, right? So it's always going to move as it's always going to move in that plane, right? Coincident planes. Okay, so I can do this again with another set of coincident planes. Now the only thing that should be able to happen is I'm going to be able to slide in and out. So one more set of coincident planes should fix that. Okay, so that's a much more stable mate. These guys are now glued together, and it's easier to select the planes there. So again, let me show you the coincident plane technique one more time. So coincident planes is probably your best bet. That is a mate that I wind up using quite a lot because it is so stable and it's so easy to select. Much easier to select than the points. So I'm going to, again, do coincident, surface, second surface, last surface. All right, one more option for these bushings to get them to come together. Because there's this center hole and those holes need to line up, there's one other option. So I'm going to go ahead and delete these again. You notice there's multiple ways to put these blocks together, and that'll happen a lot with your drawings or your assemblies. The goal is to find a way that is going to be efficient, that's going to lead to few errors in your mates. All right, so I'm going to do a mate, and this time I'm going to select concentric, okay, and I'm going to line up these two shafts. Okay, so concentric is basically going to make it so that those two cylinders are going to line up, right? But I can still spin here. So think for a second about how you would make it so this guy can't spin. There's two options to this, right? So I could go ahead and use coincident again and make these two planes coincident with each other. That's going to lock it. Now I just need to fix this guy, right? Which is these two need to be together. I'm going to show you one other way to do it. So I could also use a parallel constraint here. So this guy can spin and move, right? If I make one of these surfaces parallel to each other, this guy and this guy, right? That's also going to work. So these guys must now be lined up. Oops. All right. I still have to add that final constraint between those two surfaces to get them to glue together. So let me go ahead and do that. I'm going to use coincident. There we go. All right, so that's another option. All right, again, I am a fan of the face, face, face mate, so much so that I'm going to redo this just to make myself happy. Okay, and again, I do this a lot. The face, face, face is going to be particularly helpful for your puzzle cubes, so I'm going to ask you to make an assembly out of your puzzle cubes, and that's one really good way to do that assembly, is to do a face, face, face mate. Okay, and this last one, face, face, face is very good for squared off parts. Okay, now I'm happy with that mate there. Okay, so I'm going to go ahead and save this. And again, it's saving as an assembly file. Different type of file. I'm going to go ahead in and I would like to insert that center bearing now. So I'm going to insert components. I'm going to pull in the shaft. And this guy can spin around in space, right? So I'm going to use a concentric mate to get this to initially insert into the bearing blocks, okay? So I'm going to do mate, concentric, this guy, and that guy. Okay. There's an option here, guys, to lock the rotation of this shaft, and that's going to come up anytime you're doing a concentric mate. If I were to do that, it would basically mean that this thing could not spin about its axis. It would only be able to translate back and forth. So lock rotation is definitely an option. I'm not going to click it right now because I want to allow it to spin. All right, so this guy, right, is able to pass through, and it's able to spin. One thing I want to show you at this point is I'd like to highlight for you how these drop downs here are actually the part file imported into assembly space. So you can go back and you can edit these parts from assembly. So let's say I forget that I want a little slot here for like a flathead screwdriver in this shaft. So I'm going to go ahead and I'm going to click on this, on the shaft. This is actually the shaft file. Okay, so this is the part file for that shaft. I'm going to go into edit component, and this is now going to let me edit this file and resave it back into part space. So just to illustrate this point, again, I'm going to go ahead and I am going to make a little slot in the front of this. Okay, so I am going to sketch on this front surface. And let's say I just make this yeah. 0.25, 125. Okay. I'm going to exit the sketch, and I'm going to go ahead and I am going to extrude cut back. So same commands that I have in part space, right, to modify this file. That's a pretty powerful feature, because what can happen is you can realize as you're putting together an assembly that something's not quite working on your parts, and this allows you to go back and make those edits. So I'm going to exit component, okay, and now this is permanently modified. So when I save this, if I were to go back and look at the part file for the shaft, now it's got that center cut in it. So you've permanently modified that file. Remember that. Right, back into assembly space. Again, what this slot will also allow me to do is show you that this is rotating, right? So it's still allowed to rotate and slide back and forth through the bearing surface. I mentioned that what I'd like is for this to still be allowed to rotate, but I want it to spin, I want it to basically overhang and be fixed. I don't want it to translate anymore, but I want it to sit mid-shaft, right? So I want that to be even on both sides. So here's where a different kind of constraint is going to play in. So let me go ahead and do a mate here. I obviously need a mate to kind of constrain this from sliding back and forth. If I were to choose something like coincident, right? What's going to happen if I do coincident, if I say this surface and this surface are coincident, they're going to line up, right? They're going to line up perfectly, and that is not what I want. So I'm going to undo that. What I want is actually an offset. So I want a distance offset. These are each 2 inches long, right? So together they make 4 inches. And then this guy here is 6 inches long. So this overhang between this surface and this surface should be 1 inch, right? So I'm going to go ahead and click on this. And I'm going to say, okay, I want this distance. I can make it whatever I want, right? 1/2 inch, 1/4 inch. I'm going to make it 1 inch. And that should overhang perfectly. So here I have the constraints that I wanted, right? So this can't move in and out, but it can still spin. Think about what would happen if I wanted it not to spin anymore. How might I do that? How might I prevent it from spinning if I wanted to do that? Okay, one way to do that is to make one of these surfaces, this guy, and let's say this guy, parallel to each other. Right? Another way to do it, if I were to relax this, so this can spin again, is to go back under concentric and to edit this. So there's a lock rotation option. Now it's going to lock it wherever I positioned it, right? So right now it's positioned at this kind of weird angle and I can't move it again, right? So, so you've got a couple options for how you would, if you wanted to, lock the rotation. I'm going to go ahead and unlock that. Okay, just to review what we did here, guys. So we went and we pulled parts into 3D space to make our first assembly. We talked about various ways that we could create this type of mate between flat surfaces. We used the coincident command a lot, right? We used it on points, and then we used it on sides, on surfaces. And I mentioned that the side or face mate is one of the more stable mates. We then went ahead and did a concentric mate to put this shaft into the center of the bearing. We talked about how you can go in and modify a part file directly, and we did that by making this center slot. And then we used the distance mate to basically set this shaft to be directly in the middle of the 2 bearings. So we went through some of the basic mates. This should be enough to help you get through your fidget spinners and your puzzle cubes. All right, thanks.